All right, guys, this is your first official podcast. You're going to have to take notes with this, so I've got this up here to remind you. You need to get the note packet out that I gave you. And if you don't have that, just go to the website and print it out again. And basically, what you're going to do is, as I go through the notes, you will just basically fill in any blanks or answer any questions that might be on the left-hand side. And you are free to write down more than that or write down examples if it doesn't ask for examples. It's up to you, but you definitely need to make sure you write down the things that I put on the left or things that I leave blanks for you, because that will definitely be something that you can see on the quiz. And you'll definitely need that information for assignments and things that we do in class. All right, so let's get started. All right, so in chemistry, we deal with matter. We're basically trying to study any kind of changes that matter undergoes. So we need to know what matter is. So matter is anything that takes up space and has mass. So anything that you look at that has some sort of mass and will take up space is matter. So air, for instance, the air in the room does take up space and it has mass. It doesn't have a lot, but if you think about it, if you take that air and you compress it into a tire, it will take up space. It'll fill the tire up, and then also it will make the tire a little bit heavier. So anything that meets that criteria is matter. So something that wouldn't meet that criteria would be light. Light doesn't take up space, nor does it have mass. So there are 4 states of matter: solid, liquid, gas, the normal ones that you know, and then also plasma. Plasma is something that we don't really talk about that much, but I just want to introduce it here. Okay, so when we're talking about the states of matter, we need to talk about kinetic molecular theory and KMT. That is the basis of this theory is that particles of matter are always in motion. So even when you're sitting on that chair and it's a solid, the tiny particles of that matter are actually vibrating. They're not moving very much, but they are vibrating slightly. So if you take a solid and you heat it up, so you're adding energy to it, the kinetic energy of those particles will change. Okay, so kinetic energy is energy associated when particles move or anything moves. So if you add heat, which is you're increasing the temperature, you will increase the kinetic energy. So as you heat something up, you will get more kinetic energy and you'll get more movement from the particles. All right, so let's talk about a solid. So solids will have a fixed shape. They will also have a fixed volume, and they will have a very low amount of kinetic energy. So particles will vibrate, but they're not moving around. Okay, so liquids will have a variable shape. So it'll take the shape of whatever you put it into. So if I put liquid water into a glass, it takes the shape of the glass, or if I put it into a bottle, it'll take the shape of the bottle. Solids won't do that. They will just stay the same shape. They will have a fixed volume. So if I put 5 milliliters in one cup and then I put pour that 5 milliliters into something else, it's still 5 milliliters. They will also have a low kinetic energy. So the molecules will have a low kinetic energy. It'll be more than a solid. The particles can move around, but they're still really close together. So just like this right here. Now gases will have a variable shape, a variable volume. So basically you can take a gas and put it into any container and it'll take the shape of that container, and it'll also take the volume of that container. So you can move that gas and put it into different containers and they'll take different volumes and shapes. They will have a very high amount of kinetic energy because the particles are moving around a lot. or vice versa rather. The particles are moving around a lot because they have a lot of kinetic energy. So that's the reason that they will fill up any container that you put them into. Alright, so plasma is something you probably, or maybe you're familiar with it, maybe you've had it introduced. Plasmas are very much like a gas, so they will have variable shape and volume. However, the kinetic energy is much higher than a gas, and because the kinetic energy is much higher, the particles actually will collide with one another. So these particles are hitting each other. So they're going around with a lot of kinetic energy, and they'll hit each other, and because of that collision, they will end up getting charges. So a negative charge or a positive charge. And that happens because they have a lot higher kinetic energy. So you'll find plasma and things like stars. Our sun is made of plasma. Some light bulbs, some CRTs also. So just remember that with kinetic energy, it's going to increase going from a solid to a liquid to gas and then to plasma. So plasma has the highest amount of kinetic energy. There's a lot of energy here. Alright, so matter has properties that we're going to look at, and we're going to look at intensive versus extensive properties and also physical versus chemical. Alright, so let's look at extensive versus intensive. An extensive property depends on how much matter you have. It's something like mass. So if I have gold, I can have different masses. It doesn't change the fact that it's still gold. So if I have, let's say, 1 pound of gold, which is a lot, versus 20 pounds, it's still gold. I would still prefer to have 20 pounds though. So an extensive property just depends on how much you have, not on what you have. So an intensive property depends on what the substance is, not how much you have. So let's look at some examples of this. Okay, so boiling point. So ask yourself this, and this would be good to write down on the side too. I don't think I left a space for this, but it'd be good for you to have these examples. So boiling point of a substance. Think about it. Does the boiling point change depending on how much you have? So if I'm boiling water, will it boil at 100 degrees Celsius, or will it change if I have more water? It will not change. Water will always boil at 100 degrees Celsius. It doesn't matter how much water you have. Every time it starts to boil, it's 100 degrees Celsius. All right, volume. Do you think that's extensive or intensive? So does it depend on how much there is or what it is? That is extensive because it depends on how much it is. If I have water, I can have 5 milliliters, I can have 10, I can have 50. It does not change the fact that it's still water. Mass, will that depend on how much I have or what it is? That will also depend on how much there is. It doesn't matter if I have 5 grams, 50 grams of water, it's still water. All right, now density. Density is the mass divided by the volume. So if I take a mass of a substance and I divide it by the volume of the substance, that will give me density. Okay? So basically it's how much a substance weighs in a given amount of space. And that is an intensive property that will never change no matter how much you have. So for water is always 1 gram per milliliter. Always. Doesn't matter if I have 50 milliliters of water or 100. It will always be 1 gram per milliliter. All right, conductivity. So will a material conduct electricity based on how much there is or what it is? And that one is also intensive. Copper will conduct electricity whether there's only a little bit or a lot. It's very conductive. All right, so a physical and a chemical property. A physical property can be observed without changing the identity of the substance. So basically, if you look at something, okay, if it's hard or if it's soft, that's a physical property. I can observe that without changing what it is. A chemical property will describe the ability of a substance to undergo changes in the identity. So what that means is, does it have the ability to react to something? Does it have the ability to undergo some sort of reaction that will change what it is? So this is, if I were to take gasoline, a chemical property would be that it is combustible. So once it undergoes combustion, it will change into carbon dioxide, water, and then something else. So, just carbon dioxide and water. So if it will change into something else after that thing that's being done to it, that's chemical. Okay, so let's look at this. These are properties. So melting point. So can I observe a melting point without changing what it is? So let's say that I have ice and I melt it. Is it still going to be water? It is still water, so it will be a physical property. It's a physical property because anytime that I undergo a state change, so when I go from a gas to a liquid or a solid to a liquid or any of those changes, that is always a physical change, and I'm looking at the physical property if it will do that. So water will always melt at 0 degrees Celsius. It'll always freeze at 0 degrees Celsius. And those are physical properties. Okay, whether something is flammable or not. So if I light something on fire, will it change into something else? It will, so that's a chemical property. Density. Can I measure the density without changing what that substance is? So if I'm looking at density again, it's mass divided by volume. So can I measure the mass and can I measure the volume without changing what that substance is? I can. So that's a physical property. Okay, whether something is magnetic or not. That should also be a physical property. I can look at it and tell if it's magnetic without changing what it is. And now whether something tarnishes in air. So this is when like silver turns green. That is a chemical property because when I tarnish something, I'm actually making something new. Okay, so when we actually undergo the change, when I go through a change, then I'm not looking at just properties. Properties are whether something will happen or not. Changes are the actual act of it changing. So a physical change would just change the form of the substance and it's still the same thing. So if I take ice and I break it, it's still going to be ice. If I take ice and I melt it, it's still going to be water. So the properties won't change here. Chemical change will change the identity of the substance. The products are going to have different properties. So if I take gasoline, I combust it, I make carbon dioxide and water. Carbon dioxide and water have very different properties than gasoline. They're something completely different. Alright, so how do you know if a chemical change has happened? Well, if you look for one of these four things, you'll know. So a change in color or odor. So if I'm like making scrambled eggs, the eggs change color, they smell different. Whether a gas forms. So anytime that something bubbles up, there's a chemical change going on because it's making gas. The formation of a precipitate. That's if I were to take some clear liquid, or some, maybe not clear, it could be like a light blue, but you can see through it. And I add to another clear liquid, and I get a solid. So if it becomes cloudy or murky, I know that I've made a precipitate. That's a solid. Now also if there's a change in light or heat. So if I release light, if I release heat, it's probably going to be a chemical change. Alright, so let's do some examples. Alright, so rusting iron. If I rust iron, does it change into something different? It does. It changes into iron oxide, so it's a chemical change. If I dissolve anything into water, so if I dissolve salt into water, if I dissolve sugar into water, does it change what it is? It's a physical change, because if I dissolve salt into water, all I have is salt water. I didn't change anything about the salt or the water, I just put them in there. If I burn a log, does that change what it is? Yes, it does. It releases smoke, heat, light. It's a chemical change. All right, melting ice. So if I melt ice, will it remain, will it still be water at the end? It will, so it's a physical change. Anytime there is a phase change, it is physical. Anytime. Don't let that trip you up. Okay, grinding spices. So if I grind spices, will I change what they are? Nope, it's just a physical. I just made it smaller. That's all. Alright, so that concludes your first podcast. I hope you took some notes, and I will see you next class.